In this video, we're going to talk about why it's important to have a test data management solution that's both flexible and extensible. A modern software delivery team is going to need access to different types of data that's tailored to specific systems. That data needs to be flexible, it needs to be extensible, and the platform itself is going to be vital for making sure that each unique need is met. Extensibility gives us a lot of different value, seamless integrations, typically in the modern stack across various different data sources that live in all different parts of the organization. Flexibility is going to ensure that the teams can access high quality, compliant data when they need it at the right time. Let's walk through the platform and see how we help do that. Okay, so we're inside the Curiosity platform here, and I think there's one key concept we should start with straight away, and that's the data dictionary. It's really important to understand that any data that we work with, any type of data that we work with, be it structured or unstructured, we want to provide a definition. That basically means is we're going to capture the basic requirements and meta information of that particular database, file, CSV, XML, whatever it might be, in a manner that we are aware of the version, the type, and the metadata that sits behind it. It's really important because if you want to provide people a service, you do need to provide a version of a particular type of data that you're going to provide. As it's structured, we can then be very malleable in how we deliver that data to the end user. For example, the data might be stored here in Oracle. The end user might want it later on in JSON. From our perspective, because we have that registered version, we're able to do that transformation later on. Okay, so let's go and look at a data activity. So one of the data activities I want to talk to here is actually our pipeline. A pipeline is a really nice way of being able to structure all of the processes and tasks that you need to complete to provide an end user the ability to search multiple systems for different types of data. So for example, here I've got a Postgres database, I've got a SQL Server database, and what I want to provide my user is a very straightforward form to be able to go and ask for some information. Get me a customer, the customer needs in this particular format, they need to have this much balance in their account, they might need to be a particular type of account, whatever those particular details are. That's quite complex when you start to involve multiple systems. So, for example, here in the world of Postgres, there's going to be a schema and a structure, the same in the world of SQL Server, and therefore there's relationships to enforce, there are particular mappings that we want to make sure we enforce, but we don't really want the end user to have to do this. We just want them to be able to find an order that matches up across both systems. So from an end user's perspective, what we want to provide them is a view that looks like this. We want them to come in and ask for, say, a shipped order. Maybe in this case they're going to be a contact supplier, and we can ask for how many, and so on and so forth. So actually we simplify that experience so they don't have to know a huge amount of technical knowledge to still be able to retrieve the information that they want to. This is a very straightforward way to be able to provide end users at scale ways to access data that potentially they wouldn't be able to access or know how to access without a huge amount of technical knowledge and technical skill. The other thing about this is these forms can be embedded inside of a user's ecosystem, actually, so that, as an iframe, they can be embedded into, say, a Confluence page. Actually, the user doesn't even have to leave their sort of environment to be able to get access to the data that they need. Looking forward to the future a little bit more, I have a definition here, and this definition is actually for, again, a Postgres database. This time it's for Curiosity Bank, but I want to talk about how we leverage AI in a manner that actually finding data becomes potentially even easier. So this particular database is quite simple. It's got all sorts of different tables that are managing customers and accounts and transactions, but I have here my AI assistant that's I can leverage to ask questions. I could ask it things about some technical information, identify particular relationships in that environment, tell me about the metadata. It's actually done this already and provided descriptions for accounts and tagged particular tables for me. But in this case, I actually want to ask it to go and execute some SQL for me. So I'm going to ask it to find me a customer with a balance over 1,000. So in this particular environment, I know that I've got some customers. I know that they've got some associated account information and I want to find. is somebody who's got a balance over £1,000, $1,000, in this case, so that I can go and use that information as part of my testing. In this example, it's given me back the SQL that I could go and run, and that's fine, that's fantastic. I can pick this up, go and execute this against our database here, and it's going to go and return those users for me. If I want to, let's ask the AI. Here we go. So now I've got my list of customers, all of their IDs that I can now embed as part of an automation script. I could just go and search them in my front end. I could fire them at my API. This is now really straightforward. The final piece that I might want to do is then to transform some of this data. So this is coming out of a database, but actually I might want this as, say, a JSON file or something that I can go and push towards one of my APIs. In this case, I'm going to ask for that data in a different format. So as you can see here, I've asked the AI to provide this to me as a JSON. It's gone through and done that, and that's fantastic. It's just a very simple example of how I'm able to leverage AI, structured information, structured catalogs and dictionaries of, in this case, a database, but it could be files, as well as more rigorous processes handled by the complexities of multiple environments through pipelines to really simplify how ultimately they can interact with the platform that gives them data quickly in an environment that they don't know much about, and leveraging AI to inform them, to show them what is available and potentially what's not. And ultimately, if we're missing something, we could always add it. As we see here, if there was a record that I needed that wasn't available, I couldn't find a characteristic across my databases, across Postgres, across SQL. It's a very easy, natural language-driven way of being able to add data into this database. So throughout this, what I've tried to show is that for a modern test data management service, you've got to be able to provide real flexibility, real extensibility in a manner that is very easy for a user to come from knowing not much about a database, to being able to understand its metadata, to be able to understand the data that exists, how you can retrieve it, and do that in multiple formats. And ultimately, if the data's not there, to go and generate it. Thanks so much.